An equation on page 353, like 62, 353, and we have sine x equals x squared minus 3x plus 1. What is our first step? Yes, create a function, right? Sine x minus x squared plus 3x minus 1 equals 0. So this is our f of x. Sine x minus x squared plus 3x minus 1. Right here, I should determine the derivative. So cosine x minus 2x plus 3. And I know the Newton's method, I like to call it n of x. It doesn't matter. Call it the way you like. It's x minus the function sine x minus x squared plus 3x minus 1 over the derivative, which is cosine x minus 2x plus 3. This is what I have to punch in the graphing calculator, but not before I determine what? An interval where there is a solution. So we have to punch it in the graphing calculator. Do not delete it, because with a minor change we can go back and so in y equals clear if you have anything else in there. And just punch in sine x minus x squared. Make sure you have the radian mode, please, minus x squared plus 3x minus 1. I don't know where to start, so I go to second and table, and I'm going to start small. I already found it, but I need a 1 unit interval. So 0, 1, that's good enough. I found another interval. You may have more than one solution. I don't care for more than one. Just determine one. So I found that f of 0 is a negative number, and f of 1 is a positive number. But I also have to write, and the interval is 0, 1, and f is continuous on 0, 1 for sure. It's continuous everywhere. It's a polynomial and sine, so they are continuous everywhere. So from these conditions, by the intermediate value theorem, not the mean, but the intermediate value theorem, there exists C in the open interval 0, 1 such that f of C is 0. So this is stating the theorem. The function is continuous. On the interval a 0, 1, it changes sign on the interval 0, 1, so there must be a solution there. And we want to determine it. But now the question is, where do we start? Because we have to start with an x0. It doesn't matter as long as, careful, the denominator is not 0. This denominator. If I use 0, I have 1, plus 3 is 4, minus 2 is not 0. If I use 0, is 1 plus 3, which is, I'm wrong, hold on. For 0 is 1 plus 3, done. For 1 is cosine 1 radian, which is not 0, minus 2 plus 3, which is 1, so 1 plus cosine 1 radian is not 0. It doesn't matter where I start. So you can say, let's start with x sub 0 or x0 being this or that. It doesn't matter. Just have to choose. The derivative is not 0 at either point. So where do we want to start? We have to make a decision, though. I know you're tired. I know it's the end of the semester. I know that, but we still have to make a decision. What is it? Okay. I'll choose 1. Okay, so let's go back to y equals and insert an x minus parentheses for the top divided by, in parentheses, cosine x minus 2x plus 3. Good. So now second and quit. We go to variables, y variables, function y1, yes, and I want to plug in 1. And I get the first iteration, and you can say, oops, I'm waiting for 0 to 1. This is a negative number. Okay, that's fine. It's possible. But if it jumps too far out and goes to positive and then negative and who knows what, something is wrong. Maybe I don't have the mode in radian. Maybe there is a max min between what I chose and the actual solution. So we'll see in a moment. I copy this and I just override the 1 with the previous answer. If this is not jumping closer somewhere between 0 and 1, then I'll say, oops. Ah, okay. So then I copy, and then I copy. We haven't decided how many decimal digits, but I already have obtained 3. If I continue, I obtained 6. So this is the correct answer, 0.268881, if I want to have 6 decimal digits. Is this clear? So, but we have to copy the x1 and then so on and so forth, and you copy the last one as 0.268881. So please copy the iterations. First iteration, the result, the second one, till you show how you stop and where you stop. And that was Newton's method. Okay. Can we work on some optimization? Yes? Okay. $35 on 333. You have a problem like this, and the reason I know for sure is that one student texted me and said, can we do this problem in class? And we are going to tomorrow. I'm going to do this problem in class with them. So a piece of wire 10 meters long is cut into 2 pieces. Okay, this piece, I'm going to say it's X, and this piece, I'm going to denote it by Y. So obviously X plus Y must equal, that's it. One piece is bent into a square. So let's say this is the square, and the other is bent into an equilateral triangle. So now this is different measurements. A, B, B, B. How should the wire be cut so that the total area enclosed is either a maximum or a minimum? Not both at the same time, of course. So if I have A, what does X equal to from here? Excellent. And the same thing here, y equals indeed. So we know one now it says how should the wire be cut so that the total area enclosed is max or min. So obviously I have to determine a function that represents what? The area, not the max. I can't, right? I have to find the function that represents the area and then eventually find the max min for that. Okay, so what is the area, total area of this? It's a squared plus, we don't know. Let's go back and dig deep on this one. So in an equilateral triangle, the height is always the median, and it will bisect the base into two equal parts. This triangle is 100% symmetric. So this will be definitely a over 2. Now I need to determine the height, because in order to determine the area of this triangle, I need base times height divided by 2. There is another way, because I have the angle in between is this times sine 60 divided by 2. But let's say we don't remember that, but I can find the height. The base will be a, and what is the height? Well, from this triangle, I can determine the height. So the height will be this squared minus this piece squared, because it's a leg. So then this will be a squared minus a divided by 2 squared. Or you use sine of 60 degrees. Same thing. I say it again? Yeah, I use the Pythagorean Theorem. So this squared equals this squared plus this squared. And I already solved for h. So it's this squared minus this squared. So then we have h squared. A squared minus a squared over 4 is 3a squared over 4. So then the height must be a the square root of 3 over 2. And I'm going to replace it. So the base is a over 2, and the height is a the square root of 3 over 2. So this is a squared the square root of 3 over 4. And this is the area right here. I'm sorry. I'm sorry. It's B. It's a triangle. It's not. We're not talking about A. Sorry about that. So it's B squared the square root of 3 over 4. So I found the function, but I'm not happy. And the reason I'm not happy is because it has two variables. So somehow I have to get rid of one of them. But here's what I know. So I can solve for one or the other. So I have that x plus y equals 10, but x is 4a and y is 3b. So then 4a plus 3b equals 10. So now it doesn't matter what you want to solve for. I'm going to copy the area so I don't have to go back there. So just tell me which one you would like to solve for, and we'll replace it. And then we get the area, a function of one variable. B. Okay. B will be, so you then if you solve for B, then you'll have to multiply by the square root of 3 over 4. It doesn't matter. But I recommend let's solve for A. So A equals 10 minus 3b over 4. And now finally I'll say the area is a function of B and only of B. I replace A by 10 minus 3b over 4, and I square that, and plus b squared the square root of 3 over 4. You do not need to take this to the next level of simplification, because I need A prime. I don't really care about this function. I care more about A prime and finding critical numbers, and then I can go back and replace in the graphing calculator and find values if I need to. and when I need to. So let's find A prime. Sorry about that. You understood what the problem was here, right? I was supposed to use notation B, not A. A was here, so that's why I had to go back and replace it. My apologies. Okay, so then A prime. Careful how we differentiate this. Bring down the power. 10 minus 3b over 4 times. Imagine that this is 10 over 4 minus 3b over 4. But 10 over 4 when I differentiate is 0. So I multiply by negative 3/4. Do we agree with this? Yes? Okay. Plus, I bring 2 down and simplify with 4. And I get b the square root of 3 over 2. Now this is ugly. I have no choice. I have to set it equal to 0. It's linear, but it's ugly because of all those quantities in there. But I have no choice. So I set A prime equal to 0. Okay, let's see if we can simplify anything. So I'll simplify this 2 with this 2. And I'll take this number in front. So this is negative 3 over 8 times 10 minus 3b plus b the square root of 3 over 2 equals 0. I would like to multiply both sides by 8. Yes, by 8. I want to clear these fractions. So when I multiply here by 8, I get negative 30 plus 9b. When I multiply here by 8, 8 over 2 is 4. 4 the square root of 3b equals 0. I have to factor and move this here. So then b will be 30 over 9 plus 4 the square root of 3. Not friendly at all. Okay, so we have a critical number. So b, let's think for a moment. We want to find the domain of b. And somewhere I have this, I have to approximate. I don't even have an idea what this means. So 30 divided by, don't forget parentheses around the denominator. 30 divided by 9 plus 4 the square root of 3. I got approximately 1.9. Meters. Now I can continue before I find the domain for b. Okay, let's see, like 5 pages before. What was b? So if we use the entire length for a square, then b is 0. If we use the entire length for a triangle, then it will be 10 over 3. And it cannot be more or less, between 0 and 10/3. Okay. So now I need to study the sign. That's fine. When I plug in 0 here in the derivative, when I plug in 0, this is gone. So this will be negative, and this will be positive. I mean, this will be 0 here, and this is negative. Okay. Now, if I plug in even more than 10, 100, if I plug in 100, This will be a positive number, and this will be a positive number. Okay. What does this tell us? What is this then? I haven't plugged in 0 and I haven't plugged in 10 over 3 yet. But what is this? It must be a local min. So this is definitely not the maximum area. So we read the question one more time. How should the wire be cut so that the total area enclosed is a minimum? Well, I know exactly for a minimum, right? For a minimum, it will be, if B is 1.9, 3 times B, let's say I'm going to approximate it to 2. 3 times 2 will be 6. Roughly, it's not 6. And this will be 4. So if I want the minimum area, I would use 6 meters for the triangle and 4 meters for the square. But now I don't know which one will be the maximum. Of course I know, because if this is decreasing from whatever number to this must be when B is 10 divided by 3. What does that mean? This goes up. I have to evaluate. I have to punch in the function. Where is my function? Ugly, ugly, ugly. Let's put in the function. So we have in parentheses 10 minus 3x in parentheses squared divided by 16, and then plus x squared in parentheses the square root of 3 divided by 4. Okay, so now I want to plug in this function. I want to plug in 0, and I have 6.25. And now I want to plug in 10 divided by 3. And I get 4.8. That's all I needed. Okay, so then the first one is 6.25. This is square meters, of course. And this is 4.8. And I also want to determine this minimum. Sorry, 1.9. 2.72. Okay, so let's discuss this now. If there is no triangle at all, and we want to bend the entire 10 meters into a square, we will get the maximum possible area. The minimum possible area is when we choose 6 meters for the triangle and 4 meters for the square. And when we use the entire area, the entire length for to bend into a triangle, which means A is 0, but B is maximum, then we only get 4.8. So we don't want to bend everything into a triangle. It's not going to give us the maximum. It's not going to give us the minimum. If we want the maximum area, we'll take the 10 meters and bend it into a square, and that is the maximum area. If we want the minimum possible area, we will take 6 meters roughly, not exactly, right? Because I approximated. 6 meters we bend into a triangle, and 4 into a square. Be careful, because you have to study the sign of the derivative. If you don't study the sign of the derivative, if I hadn't done that and I haven't plugged in numbers, I would have not known. So from 6.25 indeed is decreasing, and from 2.72 is indeed increasing. See how everything fits together. Okay. Next question. This was in WebAssign. I'm sure you saw it. Okay. Okay, and I just got a text from the same student, and he's asking me to work on this problem. A fence 8 feet tall runs parallel to a tall building at a distance of 4 feet from the building. What is the length of the shortest ladder that will reach from the ground over the fence to the wall of the building? I just got this text. And I said, sorry, Greg, please wait. Where is his text? Here it is. He's such a nice young man, like everyone here. So he said, a fence, blah, 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 parallel exactly this problem. And then he says, whenever you get the chance, I know it's a holiday. And I said, I'm in class until 9 p.m. There is no holiday for ACC. So let's do it. Ready? That's the problem that he was asking too. And I started working on it, but my students came in and I didn't have to able to finish, so I can text it to him. So that's why I said but now I'm going to write it with you and take a picture and not have to do it when I get home. Yeah. Okay, here it is. 38 on page 333. So a fence 8 feet tall. Okay. Here's the building. Here's the fence. 8 feet. And it is 4 feet away from the building. And here is the ladder. And we want to determine the shortest. I didn't get the chance to finish it, so I don't know where we're getting, what are we getting for you to get. So we want this ladder to be minimum. So the length should be minimum. So let's call it W. So we want to minimize W. So obviously I have to come up with a function. I need a function that represents W. It's a function of one variable only. And then I'll differentiate, set it equal to 0, and we're done. I don't know where it takes us. Ready? Okay, so first of all, I'm going to have to denote a few things here. So I'm going to say that this is Y. And I'm going to say that this is 4 plus A. This piece is A. In the Pythagorean theorem, using the Pythagorean theorem in the right triangle, I'm going to write that W squared equals Y squared plus 4 plus A squared. Would you agree with this? So in this right triangle, W squared equals Y squared plus 4 plus A, everything squared. Agreed? Okay, so I have Y and I have A. One of these two has to go away. I don't know which one for now, but I know that I also see similar triangles here. A plus 4, 8, and Y. So 8 over Y equals A over 8 over Y equals A over. Very good. Okay, so I think I'm going to get rid of Y because there's only one Y here. I don't have to so and so. So I'm going to cross multiply. So then I get 8A plus 4 with parentheses equals AY. So then Y equals 8A plus 4 over A. Now I can go back and plug it in. In what? In here. I'm going to replace Y in here. So then I have W squared equals 8a plus 4 over a everything squared plus 4 plus a everything squared. Okay, now I have a problem here because I could differentiate this, but I'd rather take the square root. But I want to simplify a little bit if I can. So w squared is 64 a plus 4 squared over a squared plus 4 plus a is the same thing. I'm going to write a plus 4 squared over 1. I will factor out or find the least common denominator. I don't know which would be best. So I'm going to say 64 a plus 4 squared plus a squared a plus 4 squared over a squared. And it's ugly. I mean, I can factor and then 64 plus a squared. I can take the square root now. And I get w. I should put plus or minus, but not in this case. A plus 4 over a and the square root 64 plus a squared. It got reduced somewhat, not a lot. I'm going to separate into two pieces because this is 1 plus 4 over a. So I'm going to say 1 times this plus 4 the square root over a. It's an ugly situation. Really ugly. So a over a times the square root and 4 over a times the square root. That's, I can't do more. So then w prime, it's now is a function of a only. So w prime is 1 over 2 the square root of 64 plus a squared times 2a plus 4. Now this is a ratio. I have to differentiate it as a ratio. Very ugly. Okay, the top prime, 1 over 2 the square root of 64 plus a squared times 2a times the denominator minus the square root of 64 plus a squared. We are getting there, but we're kind of inching our way. It's a lot of work. So let me see if this is clear. So I have the square root to differentiate. So 1 over 2 the square root times the inner function prime. 4 is outside, but I have a ratio of the square root over a. So the top prime is this times the denominator minus that times the denominator of prime, which is 1 over a squared. Okay, so now these two go away. I have to work hard and simplify this as much as possible because I have to set it equal to 0 to find critical numbers. Okay, so the first piece is a divided by the square root. Then plus 4 is still 4 over a squared. Let's see what we have here. The least common denominator is the square root. Here we have a squared minus 64 minus a squared. Okay, so we continue with w prime. These two go away. So this becomes minus. Ah, okay. Not too bad at all. Ah, I would have not expected this though. Okay, when I set equal to 0, what can happen? The only thing that can happen is a cubed minus 256 equals 0. So a, the cube of 256 is it 6? Is it 6 to the third power 250? No, it's 216. Oh. Okay, I'm just going to write the cube root of 256. Okay then, so I have to show that this, by the time I got here, I forgot what was I looking for. What was I looking for? Max or a min? We're looking for the shortest ladder. Yes, indeed. So I'm hoping that this will give us a minimum. Otherwise, I'm in big trouble. Okay. So A, W prime, and W. So 0, of course, it cannot be infinity. The cube root of 256. So I didn't close the book. Okay, so it's one more time. What is the length of the shortest ladder that will reach from the ground over the fence to the wall, blah, blah, blah. So I am asked to find this. So I have to plug it in the function to find this. Okay, but first I have to study the sign. I'm not going to study the sign of this. I refuse, because it's positive. So when I plug in 0, I get a negative. Promising. When I plug in 100 cubed, yeah, it's positive. So this is promising. So it looks like this. So now I have to find the cube root of, I'm sorry, I have to punch in the function. Where was the function? Like 5 pages before. Wow. Horrible. But it is what it is. Okay, we punch in the function, which is 64, in parentheses, x plus 4 squared, divided by x squared. And then plus, in parentheses, 4 plus x, everything squared. Okay, so I have the function. So I will plug in the cube root of 256. So right here, you can convince yourselves at 0. Yeah, it's an error because of that, but I can plug in 1. So I know it's, oh, that was the function. I'm sorry. I didn't plug in the derivative. Sorry. So what I want right now is the cube root, 256 to power 1/3. And just give me an answer. And the answer is 277.15. What? Wait a second. Let me go back to my function. So the function is 64, a plus 4, yes, over x squared, yes, and plus 4 plus x, everything squared. And a, say it again. But I put x squared. So I wrote 64, a plus 4 squared divided by x squared. That's okay. It's still the same thing. 64 times this divided by a squared, plus 4 plus x squared. Um, so the cube root, did I put the cube root? I don't like this at all. Did I put the power? Maybe I didn't put the power. I did or I did not. I did. So what does 277 mean? Doesn't make any sense. Doesn't make any sense. It doesn't make any sense, and we know that, right? So when A is 6, okay, so this is 10, fine. And what could this be? I have to review my calculations. So this was A plus 4, this was y squared. So far, this is good. Then we wrote 8 over y equals A over A plus 4. That is correct. Then we wrote AY. That is correct. Then we wrote y. That is correct. Then we replaced it in y squared. Yes, that is correct. Everything is okay so far. The least common denominator is a squared. Yes, we factored out over a squared and 64 plus a squared. That is correct. That is correct. Then we took the square root. That is okay, that is okay, that is okay. Now here, I separated 1 over 1 times the square root and 4 over a times the square root. Correct. I differentiated this. Correct. 2 over the square root of 64 plus a squared times 2a. Correct. Plus 4. The square root prime times 2a times the denominator minus the top and the denominator prime over this. That is correct. Yes, if you notice something, don't torture me. So that's what I'm trying. So I plugged in the cube root of 256.
No, so, like what function did you plug in? Like W of A.
Yes.
So it's the same. A plus 4 over A squared plus 64.
But that is y.
You know, like the function.
This is our function. I forgot to take the square root. Thank you. Thank you, Missy. Thank you, thank you, thank you. Yes, that's what I did. It was w squared. It made no sense. Thank you. So everything is okay, but I forgot to put the square root. Sorry. Sorry, thank you. Thank you. She saved me. Okay, so insert. Of course, I put the w squared instead of putting the w. Thank you, thank you, thank you. Okay, so I want to insert the square root. Excellent. I may have to write it again. I don't know if I can insert this here. So insert. Yeah, it's probably not going to let me. I think it's safer if I just start from scratch here. Thank you, thank you, thank you. Okay, where is my function again? Well done. So at least I'm not suffering here. Thank you for not letting me suffer. Or I can put it this. So let's put it, this is the easiest to put in, this,
Yeah.
because it has the square root. Okay, thank you. I owe you, Missy. Okay. So, in parentheses, x plus 4. Okay, divide by. Let's multiply also first. So multiply by the square root of 64 plus x squared. I knew there's something it couldn't be. It's impossible. It's gonna be a number. And divide by a, or x. Okay, I did not put parentheses. I don't trust this. You may work without, but bear with me 1 second. Okay. Good. So now when I second and table, and we can check, we will check that in a minute. Ah, okay. 16.6 is acceptable. 277 is not acceptable. No way. 16.64. I agree with 16.64. Yeah, that makes sense. When I saw that, I said, wow. So here's how we check. We have y, so this is in meters. So we have y that we determined a while back. What was it? It was 8 times the cube root of 256 plus 4 over the cube root of 256. We will determine y, and we will use the Pythagorean theorem to check. Okay, so I'll plug it in to see what y equals to. So then 8 in parentheses, 256 raised to 1/3 plus 4, close the parenthesis, and you divide by, in parentheses, 256, and power 1/3, close the parenthesis and close the parenthesis. So this is y. So this is 13. Y is approximately 13.04 meters. So remember what we have now. We have this right triangle in which the ladder is 16.64. We have this which is 13.04. And here we had 4 plus a. So what was again the cube root of 256? 256 raised to 1/3. What was it exactly? How much? 6.35, yes. So 6.35. So now, if 16.64 squared equals 13.04 squared plus 10.35 squared, approximately, because if this is okay, then the answer is okay. If the left-hand side does not equal, there is a huge difference between left and right, then we have to go back, or I have to go back to the drawing board. So let's check. So 13.04 squared plus 10.35 squared and 16.64 squared. If they're not pretty close, then I have an error. Yeah, I have a 0.3 error, roughly, which is acceptable because I rounded up or I rounded down, whatever I did. But obviously I was not going to get exactly the same. So the left-hand side is 276.8896, and it's approximate. So this is to check. The other side was 277.16. And of course, this is in meters squared, because we squared. Yeah, I mean, I can put a problem like this on the test, obviously. unless I test only one thing. It took me like 3 pages, or even 4 pages. So Greg will get 4 texts, 4 pages. I don't know where this comes from. I guess it was in the book, but maybe it was something similar in the web assign. Was it? Was it? Okay, well, no one asked. Have you done this? Well, you never said. Okay, let's see this one again. Look, it took me. I know I write super big, but still, it took me 4 pages. That's why I couldn't finish before my students showed up. Any questions?